Okay, so welcome to the next meeting of the PG framework. I welcome you again. Now we are somehow more people. That looks good, so at least more people attend. Still, you will find all the recordings online, and this time I also have my power supply, so the recording won't run out because of energy. Okay. So some words, what is coming next. So the seminar phase is going to start. So I asked you last time to participate in the doodle to pick a topic. And you saw there are the questions marked out. So that's more general question that you get. And you should find solutions to it in related work. And if there's not sufficient findable, then also think of some own approaches how it can be done. So the main question will be how can we solve the specific problem that we face in the PG, and what does research provide for it. The big outcome of the seminar will be your seminar paper, 8 pages, LaTeX IEEE template. So I will put also these templates online. That's not yet online. Also the PowerPoint template I will put online, and little how it should be structured, layout, and what you should take care when you write a paper. Yeah, 8 pages, 25 minutes talk. Take care of the quality, scientific content, and writing style. And but there will be this extra document that describes what you should take care of. Regarding the seminar topics, that was the list with the topics, and and all of you participated, so I saw 1 hour ago there was still something going on in Doodle, so still some people accessing, but all of you participated, and it was quite feasible to find a match so that everybody gets either the first choice or one of the yellow choices. Okay, and this is the location. How it came out, so based on Doodle, so all topics have a person, that's good, and no person is twice, that's also good. So please find yourself, and so all of you either got the green one or yellow one, and yeah, you have now the option to, so should I jump back to see what your topic is? Okay. Yeah. So now you have still the option, okay, for 1 week, let's say that if you want to change topics, to talk to the other person who has the topic, to change. To change it in between each other. Okay, that was the important part. That took a little while. And now I still want to say some words on how to approach a seminar and what to really take care of, because last time I didn't finish quite the organization. So if you start reading, I can really recommend Scholar, Google, because there you find also PDFs, and they are big to publishers, IEEE and ACM. If the paper is from them supported, so it's a conference from IEEE or ACM, then it could be it's typically very good. And if you look for the references to have a good overview, a well-formatted one, and go to DBLP, there all the references are very precisely listed. That's still important to say, so take care that you know what plagiarism is, that you do not copy-paste from the paper, so do not take over good solutions word by word, also do not summarize sentence by sentence, don't reuse figures, be precise with citations, and if you are unsure what is correct and what's not correct, how to approach, then ask me. That's better to ask than to run into a trap, let's say, so you should take care. Okay, what kind of tools? So LaTeX is to be used, and template will be in LaTeX. That helps also at the end to compile a common document out of all your papers. And if you have some preference, if probably you use LaTeX, then you will use your old tools that you know. If you didn't use LaTeX up to now, then I can recommend these ones. For Mac, there are also some solutions, but for Mac I would recommend to install a virtual machine with Linux and use Kyle. For bibliography editors, you can use Jabra for Mendeley. There are some programs really supporting bibliographies. I personally prefer text editors. There you see most what's happening, but that's more a question of taste, probably. Okay, yeah, how to approach next. So what is important also to know. So the next steps will be to, once your topic is fixed next week, so now it's still 1 week to change if you want to, and then once your topic is fixed, then you can, then you should already start with the structuring of the paper. That means you should create a document using the template in which you list which kind of sections you will have, what kind of subsections you will have, and what roughly will be inside. That's 1 or 2 pages where you describe what will be the content of your paper and what you will write about, and probably also which kind of papers you will also consider for which parts of the sections. And once you have it, you also have to register at this website EasyChair. That's a non-profit organization, I think, at least for the authors. And there's the conference called Peer-to-Peer Framework 2013. And there you can upload your paper. So you have to fill out your author name, your affiliation, to which university you belong, and upload the first 1 or 2 pages with your paper structure. Yeah, it's a web-based conference system. You have to submit your paper. Later on, you will also have to bid for paper review, so you will also have to pick, but later on, so 1 2 months, more 2 months, let's say. You have to bid also for other papers that you want to review. It's also relevant that you use both for the reviewing and the submission of your papers the same email address. What I suggest is, I'm not sure whether we agree on that one. So, because you sent me also other kind of email addresses, so what do you prefer? So either we could use the email address that you have listed in Paul, that we can use, or we can also use the Google Mail account that you listed and sent me. So which one do you prefer? Who is for the email address that is in Paul? Okay, and who's for the email address that is that you sent me and is your Google account? Okay, then we use the Google account. And to make sure that you also get the correct one, I will also send you to your email accounts the one that I will think that you will use. So because I have to invite you as reviewers for this conference, and they're the email address count, so I will also send you the one that I know from you is your Google account, and you can confirm it or say, no, that's something else. And that ends in, you only will have one account and one author per paper, and you can edit it, and yeah, and we have to, that's the only reason for this email address is that we are both reviewer, so program committee member, but also the author, and that they are the same, and we need only one email address. Okay, so submitting as author, so 1st of May is the first deadline to submit your seminar paper structure and literature list. Of course, this is not the final one, but it's a rough first good estimation that I can see whether your paper is going into the right direction, you are putting focus on with the right strengths on the different topics. And end of May is the submission deadline for the seminar paper. Yeah, the submission pages, yes. And later on, after that, we will go into this reviewing phase. But how this works and what you have to do there will be an extra slides in some weeks. Okay, example structure. You cannot read so much. It's not so well presented. But what you should see is that so this is a example structure, how it could look like, and there you describe basically. So here he described how many pages for which sections he will have, what will be the subsections, and which literature he will use. Another example looks like this. So here you see also the sections, how what will be presented. There's also, so he writes, I will write about this and that. I will use paper 40 here, and roughly that amount of pages I will use for it. So this is what I think of how the structure should look like. So 2 pages, you describe the sections, what will be inside, which papers you will use as an input, and roughly how much space will every section and subsection take into. Hello. Okay. Do you have some questions for this paper structure? Okay. Okay. Yeah. Okay. This is for the reviewing. Yeah. Okay. So what will happen with the reviewing? So once you registered in EasyChair, and once the structure is also uploaded, I will invite you to become a reviewer of this precious and highly renowned conference called PG Framework 2030. So I would be very pleased if you accept the invitation to become a reviewer. Then you have the option for every paper to say whether you want to review it, maybe no, or whether you have a conflict because you are very good friends or so. If you do not make a selection, that will be made automatically, and EasyChair will try to compute an optimal review assignment based on your choices. So you can also make more choices, you can have less choices, but anyway you will receive 3 papers that you have to review. Okay, so there's quite some time, okay, 1 month, to review, to make your selection which papers you want to review. And yeah, little information in EasyChair. You have to be in the roles. You can have different roles. You can have the role of an author. You can have the role of a PC member. You have to switch when you want to make your selection. But that will be presented in more detail later. Once, so let's see, in some months, 1 month. Okay, 3 papers you will get to review, and there's a review form that you should apply. So here it's described how you can give a review for a paper. So you will be assigned to 3 papers. Then you can select, okay, if you choose reviews on the website, pick my papers, add a review to one. Then you get the review form and you have to fill it out, let's say. And then you have until the 6th of June, midnight, German time, time to finish your reviews, to fill out the review form and upload it again. Of course, you can improve your reviews, so but all of it will stay in the system. Okay, how does the review form you will see then? Okay, just that for the seminar part, and now I want to say some very few words on how it continues after all the seminar phase. So we will have at the end of June a kickoff workshop where all of the lectures are finished, all of the seminars are finished and presented, and you are well equipped with lots of knowledge and motivation to address then the practical challenges that lie in the front of us. Okay. How does this project phase then look like? So what is the organization of it? I think, did I say something to it last week? Yes? You not? Okay. Then you know this picture. Yes? Okay, good. So important what you should take out of it. We will have 2 or 3 phases where we have a meeting before. We decide what are the most important next steps to do. Then we split up in smaller teams, and the smaller teams work on their own and solve the problems, and then there's some merging and a point from where we start that again. So that's important that I think I then showed already. So we split up in teams, close collaboration. It's important to have all the testing and documentation. So there's some words what's not tested is considered to not work, and what's not documented has never been done. So both aspects are very important to do. And also at the end of the PG, you have to hand in a documentation on all the work. So it's good to stepwise work on the documentation and not have it all for the end. Yeah, merging of results, alpha beta tests are important to do. So it's also planned to first that you use it from some time on so that the peer-to-peer framework for social networks is used by you from some time on, and also probably hopefully we can also use it in the winter semester in a lecture. That's also a hope that will work out. Okay, sorry. Yes. Yeah, that's the clever saying, what's not tested does not work, what's not written, documented has never been done. And I also found out recently that's very, so if you are looking into software engineering, we use the Scrum method. So we as a team find out what we want to do next and split up, and in smaller persons we do it. And that's also something later on you will benefit from in knowing. Also what can happen, and what's also happened with the last PG, so out of this documentation, also some publication will come out with you or so with the PG members as authors, so it's beneficial for everyone. Okay, that's the last slide, I think, before we start with the lecture. So what's important with documentation? To write down, it's on a very long term, what you did, why that thing you did was important, what is the purpose, why it's a problem, how it works, the mechanism, how you tested it, what are the test results, and before starting a new mechanism to implement, basically also to talk about it, what are the arguments for it and against it. For the testing, it's important first to test that it works, and second to measure how good it works. So what are the metrics? So how do you measure the performance and the costs of it? When can you say that it's a good solution and when it's not a good solution? And then to think of the metrics, how to show that it's a good solution, and if you test it, to use good setups with round numbers, 100 or 1000 nodes to test it. Okay. Some pictures from CeBIT, I think that I showed. So that's basically for the organization. The important things to take with you now is start with so if you are happy with your topic for the seminar, then start already with the structure. So I would suggest to download then the template that I will put online today. And have a look at the description, what kind of formatting rules and how the approach should be, and then to already start with the topic and have a look. So what is the question? What kind of sections could I have? And already start working on it. And because if you never use LaTeX, it takes probably some time to get into it, and it's better to come up with the problems earlier that can be solved than later if time runs out. And to also get familiar with EasyChair. Test it and upload or register at least at first your topic, so to also identify whether some problems are occurring in EasyChair or not, so that you do not miss the deadline for uploading your paper structure. Okay, this is for the organization. Some questions, yeah?
Does the seminar topic has any influence on the team we are part of during the workshop?
So whether the seminar topic has influence on the teams you are later in? No. No. So it's so on one side you create with that seminar topic knowledge that you can later on use. Of course, that's why you are more familiar in that area. But you can still the teams are not based on the seminar. So you will yourself say, I want to work with these people on that topic, and that will. So I will not put you in any team. It will be more teamwork, how you decide in which teams you want to be. Okay, then I would like to start with the lecture. and the background information on peer-to-peer systems, some topic that we need to know. Okay, one moment. Do we have some? Okay, good. Okay, so then we start with peer-to-peer systems and what the topic, the lectures will be about. So the lectures will be about peer-to-peer, peer-to-peer overlays. So what are these networks, what they can do, what they cannot do. We will also always have a close look on what is relevant for the project group, basically. And in project group, we use some mechanisms already. So we use pass-tree, that's an overlay. So we will look at the background of overlays and structured overlays and how pass-tree works. We have also some monitoring in the peer-to-peer framework. We will have a look how that works. We will have a look on security issues, and we will all this background, what is already somehow takes place in the peer-to-peer framework, we will get the background on, and we will also see the open challenges and what kind of solutions probably are there. So that's also additionally to your seminar papers, some knowledge that is useful when we want to find solutions to some open problems. Oh, okay. Moment. Good. Okay, so today, chapter 1, decentralization, overlay networks, and peer-to-peer systems. Who of you already participated in this kind of, in such a lecture on peer-to-peer systems? Okay. So, okay, 2.5. Okay, that's, yeah. Then it might be not very surprising for you, but still a good to have a repetition. Okay, for all others, it's important to listen carefully. Okay, so some words on the motivation why peer-to-peer is coming up and was coming up and probably also in future will have a relevance is first of all that large sets of resources available. So in this lecture, content and capacity, so resources describe both objects, data objects, documents, that kind of stuff, and capacity like CPU power, storage space, and so this technically hardware related resources. So we have lots of resources available. So both programs, data, information, also bandwidth, and also the demand of the users grow. So what we consider today as sufficient for any kind of applications, like it has been done some decades ago, this is not enough. So also in future, this demand that we have will grow, and today we would say 1 gigabyte per second is sufficient for anything that we can think of, but 1 gigabyte per second bandwidth at home is probably not sufficient in 20 years or so. So it will grow, and both processing speed and the amount and size of content. So you can think of HD video will be in future something that is considered as low quality, and we want to have multi-dimensional 3D with any kind of features, extended documents. So the demand of the users will always grow, and also demand goes beyond capacity capabilities of single devices. So we want more than we have also in future. And what is the good part is that we have Moore's law and it's still working. So the computational power still increases, doubles every 18 months. That was the law, but it still works out. So also if we consider this, in future we will have in 10 years much stronger devices than we have nowadays. And if I think when I started my how I worked in 10 years ago, or let's say 15 years ago at school in computer science, then I had a computer with 1.6 gigabytes of storage space. That's now not really serious. Okay, so computational power is increasing, and also bandwidth is increasing. There's Glider's law, which says bandwidth capacity triples every 12 months. Now we have LTE, also mobile internet is covered, and Deutsche Telekom now wants to introduce 100 Mbit at home, and Google Fiber, and all that is coming. So also bandwidth and computational power increase. And what also happens, ubiquitous computing is the topic. So if people ask how the future will look like, they say, okay, we will have more and more devices at home that are connected. So what also increases is not just the computational power and the bandwidth, but also the number of devices per person. And yeah, also the PC count so increases. So we also have more and more devices at home. So now we also have a mobile phone that's very powerful as a desktop PC 5 years ago, and tablets additionally, and so there's lots of resources available, and that is not really used currently. And where do we see it? If you look at the internet, so we have the internet somehow as a black box with routers, and we have these endpoints. So that are at the private person side, they are having some DSL or any kind of connection to the internet. And these private devices are in the majority at the end. And like I said, since 2000, it's really that the devices are getting more and more powerful. And I mean, they're getting more and more powerful since all the time, but also with some compression and some new approaches, content got manageable. So also it was feasible to share them. And what also comes as a trend that was not presented in the last slide is this user-generated content. If you look at the main websites people visit, like Facebook, YouTube, or such, then all what is presented there is not made by the company Google or by the company Facebook, but it's user-generated content, and they are just these platform providers where people come together. So what we have is that we have more and more powerful devices, more devices per person that are interconnected, and we have more bandwidth, and all the content comes from the users. So at the end, here at the edge of the network, we have very powerful devices, and all what is generated, all content that's generated is mainly from here and also consumed at this. And then the question is, why don't we just create some connections from node to node? If anyway they create the content, they consume the content, and they are powerful enough, they have the bandwidth, why don't we just connect them to serve each other and to help each other out, and to create a self-organizing network without any central instance that helps out. So they are all powerful enough so that they can provide this functionality. And also, if you look at the future, this is not some idea that will, because of the trends, die out, but more and more the trends are enforcing that it will come to this point again. Although the cloud is currently more popular, but the trend is more still towards peer-to-peer. Okay, and just have a look how it looks today. So how it looks today, how the world looks today is we have the clients at the bottom, we have the network, we have an index server like Google that tells us, okay, we tell to the index server, I'm interested in the newest Justin Bieber song, and it tells us at which website we can find it, which providers they are, and we get content from the providers. How the peer-to-peer network looks like is that we have the network, and we create a new one on top of it. It's called advanced, it's called intelligent, but it's just a redirection to other nodes in the network. So if we state, okay, I'm interested in the newest distribution of Ubuntu that's free to download, I can ask this network, and this network is somehow created by these nodes. They solve my request, and I'm assigned to that node, and I can download it. So what you see is all the providers are mapped then to the nodes. The nodes are the providers, and also the indexing and the assignment where I find the content is done in this advanced network. But this advanced network is also consisting of the nodes. So we just have at the end nodes or peers. What is the term? And why is it called peers? Peers means of equal rights and of equal quality, and we just have one class of nodes at the end that fulfill all that are both consumers, providers, and this organizers, let's say. Okay, and where are now the problems and the challenges? The problems is, okay, we have a large number of nodes participating. Many nodes, many content objects, and the main question, how to implement this intelligent network so that we find the content that we are looking for, that we have it always available, even if nodes go offline. How do we measure how many nodes we have in the network? So how do we implement this intelligent network? Okay, yeah, and what I said, so what peer-to-peer does, it creates this overlay, this advanced or top network, and this overlay offers the mechanisms that we all need, at least to find and look up what is wanted. So if you are looking for the newest Ubuntu distribution file, then we can state a question to this overlay, and it will answer us where it is. And the overlay also only consists of the peers. And after we found what we wanted to have, we interact directly from one peer to another peer, and we exchange the data directly. So this is somehow focusing, the motivation is focusing on file sharing, but you can think of other use cases at all, because this advanced network is not focusing on file sharing. So what we, for example, have is more distributed storage in the peer-to-peer framework. So what we do is, we don't have the Facebook providers that tell us where to store the data, but the advanced networks help us to identify where should we store our data, and also replicate it, for example, so that if some of the nodes go offline, it stays online. And what it also does is, if we want to have, for example, some chat, then it helps us, okay, now these three nodes want to chat together, then how can a message that they send be received by all of them? So what the advanced network basically does, it's a collection of clever mechanisms that maps the nodes to each other and helps out to provide the functionality that they want to have. And this is, from the logical part, it looks like it's an independent part, but it's only consisting of these nodes and how they interact with each other. Okay, so what are overlay networks? Some words on it. So what is an overlay network? If you think of the internet, or how it's from the peer-to-peer view, it's the underlay. There we have different kind of overlays, TCP network. It might be also some mobile network somewhere, but at the end, this is the TCP IP network where we can communicate with any node in the network. And some nodes in the world say, okay, let's create together an overlay. And this is presented at the top. So they say, okay, we create an overlay. We somehow find out who's else in this overlay. And we create connections to each other. And in the second network, using the functionality of TCP IP, we can communicate with each other. And we can think of some protocols to provide some new services, some new functionalities. So, for example, the functionality to store a document and to retrieve it based on its ID. So to find which peer is responsible for it based on the ID of the document, and other nodes that want to retrieve the document also look up the ID and find it. So these functionalities that are implemented by the overlay are not available in TCP/IP. So with the overlay, what you get is new functionality at the cost of a little bit higher traffic. So what is the network? Interconnected nodes. So the overlay, it provides a new service. It defines how the nodes interact, so protocols you need for it, addressing, routing. So it's basically a new layer in the network stack with its own IDs, with its own routing protocols, with its own elements. So an overlay network is a network built on top of one or more existing networks. And it is also logically a new layer on top of the network, so it adds new abstraction, a new interface. And if you think of what other overlays beside peer-to-peer you know, then virtual private networks are typically one. Also virtual private networks, so if you want to connect to the university from outside, then you start your little program, and it creates, it then joins the overlay of the university, so it participates only with nodes in the university for communication. And what also is an overlay is, for example, Tor, which helps you in anonymous routing and websites that you want to have a look at. And also there the communication, so this is a new layer where the communication that you introduce, so you say I want to have a look at some specific website, then it goes through several Tor hops and it comes out somewhere in the world, and the website is downloaded, and then through this other hops it comes back to you. So this is also some overlay. Yeah, peer-to-peer networks form an overlay. We will see what diversity there is, how this peer-to-peer overlay can look like. It uses the functionality of the TCP/IP, so we assume we can send a message from node A, with which TCP/IP port is known, to another node B, so that they can do. And if we also think further, also the IP networks and overlay somehow, because there's not one global network connecting all devices, but there are sub networks belonging to different internet service providers. They exchange their data at this internet exchange points. And so if you think in layer models, in the TCP, in the ISO-OSI layer model, for example, then it's just a further layer on top using the functionality of below layers and providing by itself new functionalities. Okay, and what the peer-to-peer overlay and also IP overlay and also other overlays typically bring with them is their own addressing scheme. So if you have your IP address and port and you join a peer-to-peer network, then you get a peer ID, for example. So this is that's an ID that is used in the peer-to-peer overlay for routing and all its purposes, and the original port TCP IP address is not really seen in the overlay. Yeah, okay. Some of the functionalities of the IP and peer-to-peer overlay are similar, but that's not a focus. Okay, what's the good part? So they introduce new functionality without, and you do not have to change the whole network, the whole IP network to introduce this functionality. So all of the nodes who want to have this functionality, they participate in the overlay and they have the functionality, and all others who don't want to, they're not bothered. For peer-to-peer overlays, typically search or lookup for content is implemented, and that's something that's not available below. You do not have to deploy new equipment like new switches or modify the existing Cisco software protocols, so you leave it untouched. You just put something on top of it, use the things below, and get the functionality. And it's also allowed to, what it helps out is this new functionality, like I said, is only used by those who are interested in it, so they can bootstrap. You can join this new functionality one node by one node, and you don't have to have a switch day like an IPv6 where you really would have to ask all to switch at the same time. So it's good to have. It provides functionalities. It's easy to do. And if it's what are the disadvantages? So it introduces overhead. So by your new protocols for the overhead for the overlay, you have of course more traffic. It's another layer in the network stack, more packet headers. Okay, it's getting complex. Okay, you get more and more layers of functionality that might interfere with each other. There might be interdependencies. Okay, you might have the same functionality at different layers. So it's even more costly. And some functionalities you cannot do. So, for example, real-time capabilities, so that the packet really arrives at a specific time. If it's not supported by below layers, then you have problems. And you cannot do the higher layers. Also, security sometimes it's the case. But what do we see? Okay, it's getting more expensive to do. We have more traffic, but who cares? Traffic is not so expensive nowadays. And some functionality cannot get if it's not in the lower layers. Okay, we have to take care, but it's all manageable, so it's good to have an overlay. Okay, some examples. What kind of peer-to-peer overlays exist? So there's lots of this content-centric networking or routing, so that you have objects, object IDs, document IDs, and based on this document ID, you store your data, you retrieve it, and the overlay is supporting really then this store and get functionality. What can be also there is some recommender, so that you get out some recommendations which documents are fitting. You can have friend networks where only friends connect to each other and their friends connect to their friends, and then you have a worldwide net of friends, and you can do some anonymous or trusted communication. So also the search and the lookup for friends is supported. So there are different overlays addressing different parts. So what we will have look at the peer-to-peer framework is more the storage retrieval and content-centric networking, because we use the peer-to-peer overlay for two reasons. First, to implement the distributed storage, and second, to implement this user-centric networking, so that we find the users that we want to communicate with, so that we can really look up the friends that we have. Yeah, other non-peer-to-peer overlays, which are private networks, IP over ad hoc networks, or Tor, like I said. Also application layer multicast for streaming. Okay. So what is now, okay, now we know what overlays are, but we don't know what peer-to-peer is. Because peer-to-peer also comes with its own characteristics that makes it different, makes it a different problem case than, for example, grid computing or mobile ad hoc networks. So there, one needs to know what are the explicit characteristics. Okay, this picture shows the layering basically before we join into the peer-to-peer considerations. So here we have a one-to-one MAC layer, here we have the internet, then some of the nodes connected to the internet service providers, they create a new network, they connect to each other, and that overlay network provides some functionality, probably to look up some content, and once you found the content, then you have the direct communication between each other. So the good thing, and what we assume, is that every node can create a connection to every other node in the overlay. And what are the characteristics now of peer-to-peer? So first of all the relevant resources, both documents and the storage and bandwidth and so, the node capacities are at located privately operated nodes. And they provide these resources uncontrolled, so you cannot force them to do. It's voluntarily. And that creates sometimes problems. At least that's a challenge, so it's not easy to handle it, because people who do not want to provide resources, you cannot force them. And so you just get what you get, and you have to live with it. Also, okay, the distribution of the resources is widely spread. It might be all across the world, like the PG coming from all across the world. And so you have some and it might be that the document that you're looking for is in China, and you are sitting in South America, and you have to find still the content that you're looking for, although it's widely spread. And also the node the capacities of the peers are heterogeneous, so very diverse. So we have very strong peers with lots of bandwidth, we have very weak peers with only small bandwidth, CPU power, storage space, all is very fluctuating and very diverse and very powerful, very weak, and it changes over time. So the problems is, okay, we can only use what we get, so we cannot say I would like to have 100 nodes more that are very powerful, that we cannot do. So we have to see, okay, what do we get? And we get lots of different peers, and we have to live with it. And what also comes into play, not just that they are very diverse in their capabilities, they are also not online all the time. So they go online, they go offline, they come online, and we cannot predict when this will happen. So that's difficult. So we have lots of different devices that have different capabilities. They go online, offline, and that's the only thing that you can use to create a reliable storage. So it's difficult to do. But what we can do is, and what we do is that the client and server functionality is combined. So every node that is in the network, and we assume that nevertheless, also if it's very weak, it should provide its resources as good as it can, and provide also content and help out in creating this overlay. So every node participates, it's not just a consumer like it's in a centralized approach, but also helps out in creating the overlay and provides content to other nodes. And communication takes place between peers directly, so one-to-one, and without central man in the middle or something. And we also assume that all peers can communicate with all other peers. Sorry. Okay. Good. Okay, what else do we have? Yeah, a self-organizing system. So, okay, so the nodes are all very diverse. They are very different. They go online, offline, and we do not have any reliable centralized points. So that what we have is only the nodes, and they should organize themselves in a way that they provide the services and functionality that we want. So no central control, no central provision of the service. So the nodes that we have to find each other, coordinate each other, and make sure that the functionality that the overlay should provide is provided by them. Although they go online, they go offline, they are different in their capabilities, and that makes it difficult to realize. And we cannot enforce them anything to do. They have lots of autonomy. So if one user decides he switches off his device, then it switches off. And we cannot assume that they are trusted nodes or very powerful nodes. So most of them are very similar in their rights. So we have to come up with some code, with some protocols that we can give to all nodes at the same time, and that should work. So we cannot change the code also later on. So we cannot ask people running a peer-to-peer network, please update your code, you have to do something special now. So all the protocols that we create must be in a shape that once you install it, it fits to any device, and it's never changed again, and that's difficult. So yeah. Okay, so these are the characteristics of peer-to-peer, just to have an overview. So some nodes emerge, they find each other, and they can connect to each other, and they provide the resources, they provide content, they organize themselves to make access to these content and the resources. Peer resources are heterogeneous, the nodes go online, offline, and yeah, at the end you just can use what you get, and you have to make the best out of it, and it has to be self-organizing, and there are lots of challenges around. Okay, just a comparison to other technologies. So why is it now different? So okay, the most prominent one is of course the servers. So the easiest part is, okay, you have one server and clients. How do you find the server that you are looking for that provides the content? You look it up in Google. And that's very easy, that works well, so it's reliable. If the server is online, then you get your data, and that's okay. But the server needs to provide all resources, and that's costly and expensive to operate. And for the peer-to-peer framework for social networks, to make the comparison, so there are some measurements that say for every Facebook user, Facebook has to pay costs in terms of $1 per year. That's how much it costs. And that means that you have $1 billion a year as operational costs at least, and you still need your income. With a peer-to-peer approach, you don't have it. So typically, if all users participate, you do not have any costs. Okay. Grid computing was once a topic that has gained some attention. That's also similar like peer-to-peer, because you have their different. What is grid computing? These are high-performance data processing centers. For example, for scientific applications like molecule folding, or I don't know what. And there you also have distributed sites which provide their resources, but these sites, so you might have a data storage site somewhere, you might have a computational site somewhere, or distributed somehow. But these are all some companies that agree on by contract to provide the resources and to create this virtual organization which operates then. And so there you don't have churn, and heterogeneity is not given, and your everything, the functionality is guaranteed by contracts, so it's not so challenging. Also the cloud we have, just as a comparison. What's good? Okay, we have a distributed pool of resources, so we don't have one server anymore, but it's more a big bunch of servers in a pool. And internally, so this so in this Rechenzentrum, in this server farms, they also use some protocols that came from the peer-to-peer networking. But so, and then you have the server farms and lots of resources, lots of clients requesting content, and the best servers identified, or the content is distributed, stored, and then provided back. So the good thing is, and why it's easier to operate the cloud, is you don't have malicious users in the network, in the server farm. None of the servers will try to attack the others, but it might be the case in peer-to-peer networks. And so in peer-to-peer networks, you might have attackers between each other. Also, the servers don't go online and offline all the time like they do in peer-to-peer networks, and the servers are mainly the same. So you can have some clever protocols that answer to these requests, and you can make some assumptions on your node, so it doesn't have to consider security too much or node failures. So it's easier to do. And the problem is, so we don't have the option, so we have the problems. So we have churn, the nodes online, offline. They are malicious, they are trying to attack each other. We have different kind of devices, and we have the support for our software, all of them. We cannot update our software once it's deployed. It's lots of unpredictability, distributed access points, and so it's more challenging to find good solutions there. Okay, that's the overview on peer-to-peer characteristics. Do you have some question on that? Otherwise, I would jump into the categorization of peer-to-peer overlays. So there are basically two big types of overlays. So what kind of peer-to-peer overlays do we look at? So we look with high focus on this data-centric overlays, where the question is, okay, when I want to store some content in the network, so the left one, where should I place it in the network? And on the right one, if I want to download some content, where do I find it in the network? And there are two main types of requests. So the one is lookups. That means that you know the ID of the object that you're looking for. It's like an URL, or it's like a number that clearly classifies the object. And then you say, okay, I have this object with this ID, so I want to find the exact place for it, where to store it. And the other one asks then, okay, I want to have this object with this specific ID. Network, please give it to me. So here you know exactly the ID. So for example, a hash of a file. The second one, request type is the search, where you don't know the object ID, but you know what you are looking for. So you use Justin Bieber song. And then you say, okay, I want to have a song by Justin Bieber, it should be MP3, it should have a title. And then you send out your request, and objects or resources fitting to your search query are responded to you. Then you get a list and you can search from, pick from. Yeah. And there are two main classes. So the upper part, I think that we don't will go into detail. We will please focus just on the lower part. There are basically two classes of peer-to-peer overlays that also address these two types of requests. So the first one are the structured peer-to-peer overlays, where we have clear object IDs, we have peer IDs, and they are both in the same ID space. So if the ID space is from 0 to 2 to the power of 160, then both the peer IDs are in this interval and also the object IDs are in this interval. And the clever part, so why it's called structured, is because every object ID has a node responsible for it. So every object ID is assigned to one single peer. So the easy thing is, if you want to store something, you have to find this single peer based on the object ID and store it there. And if somebody wants to look up the content and knows the object ID, then he also starts a lookup, finds the peer who is responsible for the desired object ID, and if the object is there, he gets it. So you have this responsibility in structured overlays. On the other side, there are unstructured overlays where object IDs might exist, yeah, they exist, but they have nothing to do with the peer IDs. Yeah. So they are not bound to each other. So that means if you have an object, you typically just leave it at your own device. So objects are hosted by uploaders directly, so you do not send it around, you just keep it for yourself. And if you want to search, then you have to look which nodes in the big wide world have it. So find nodes of interesting objects. So there are so what we use in the peer-to-peer framework for social networks is this structured overlays, where we have clear IDs. And it's because in social networks it's somehow easier to have it. So we are not looking for any person named Alice or Bob, but we are looking for clear persons that we are friends of, typically, with clear names. And we have our clear profile ID, we have our photo albums, we have, it just makes it easier to have, or when we have a buddy list, then we have a clear ID for every user and we can look up their content directly, and we don't have to look for all Alices in the world and check who's now our friend. So we will focus more on structured overlays, but still you should also be aware how unstructured overlays work. Okay, yeah, here again the both approaches. There's also a reason why this is presented. So first, what does the lookup do? So you give it a key. That's a node ID or an object ID or document ID. And what it gives you back is the responsible peer. So contact to the responsible peer, and that you can ask either to store your data or to give the data back that you are looking for. So the good thing is every object is uniquely identifiable. Protocols guarantee if the object is there, you get it. If it's not there, then the responsible peer will say, I don't have it. And the object location can be made efficient. So for every peer, for every object ID, you can calculate then the position in the network and store it there and also find it there again. So you don't have to contact too many nodes in finding it. Drawbacks, okay, you have to know your unique name. So you have to know, when you're looking for Alice, then you have to know Alice user ID. That's also the something that we faced in the peer-to-peer based social network. So you have somehow to organize your data of the people who you are looking, or who you know. So of course you have your friend list with their unique names. Of course you also need to make, okay, so you have to have your friend lists with their unique names. You have to have a list of your group IDs where you are participating in. And how do you find, how can you contact somebody whose user ID you don't know? That's the question. And what we do currently, so if you want to contact somebody whom you don't know, first of all, it's a tricky question. So whom do you want to contact directly and you don't know who it is? So you will have some ways to find him either in groups or in other kind of lists of other people where also his user ID is listed. Okay, to the lookups again. What you also have to do in the overlay, you have to maintain this address structure. So if a node goes offline, then, for example, you have to make sure that the new node who takes over the responsibility also knows that object, and that you have a quick way to the object IDs that you are looking for. So you have to take some care in the maintaining so that your lookups are resolved efficiently and quickly and correctly. The full text search, the other one, is so this Justin Bieber example. So you define a sequence of words that define your search term, like Justin Bieber MP3 and I don't know what. Or in our case, University, Paderborn, student, and you send out the search, and then you get a list of all students probably being member of the University of Paderborn. So you get a contact to all peers, so a list of peers with have matching search terms. So you don't need to know the names of the people you're looking for, but in the worst case, all nodes in the network have to be traversed and have to be looked up, and that's hard to make efficient. What we have in the peer-to-peer framework now is we have, beside the lookup, so we use structured overlays, but we have also this search mechanism implemented. At least we have it implemented, so it can be used, but I think there's currently no application, no smaller use case where it is used. So it's inside, but it's not used. Matching query, what you can also do is to have something like logical conditions. So I'm looking for persons at the University of Paderborn, and they should be older than 30, or they should be male, so I don't know. And then you get all entries fulfilling the logical conditions. I think this is also implemented in our peer-to-peer framework. And that's also implemented in the peer-to-peer framework. Range queries, so that you can define, that you can look for entries within a range. So let's say, so in a social network, the example is always, okay, I'm looking for a girl, she should be this and that age. So you define the range of her age, and then you send out your request. A more serious or more normal range query would be, I'm looking for an object, and the size or the age of the object should be between a specific range. Okay. that's also supported. Okay, some classifications of peer-to-peer overlays. So what kind of classes exist there? So just to know the terms. There are pure peer-to-peer overlays where you have basically just normal clients, just normal peers, and only all decentrally, no external elements. There might be also, I just present probably the other part. So, okay, if you have good eyes and can still see it. So there are also centralized peer-to-peer networks, which sounds for at first strange, but from the terminology they still exist. So what you have there is a server which maintains the location where objects are placed. So all objects are placed at the peers, at the normal nodes, but you have one server which maintains the list, so the index. Index means the location of objects. And Napster was, so the first peer-to-peer overlay was like that. There you had some MP3 files and you told the server, okay, I have this file, and if somebody else was looking for it, you asked the server, and the server responded back with your ID and contact address, and then the direct communication took place. And in between, you could have something hybrid where you have centralized components, several servers, and still the same principle, just you have more servers, and if one server goes offline, then it's not a big deal, but the other servers can help out. Kazaa was like that. No, eDonkey was like that. Kazaa was a little bit different. Okay, then, now this is a different kind of classification. So, classification number 1 is pure, hybrid, and centralized. Most of the overlays that we look at are pure. New classification, flat and hierarchical. And the flat overlay means that you have all nodes in one overlay. That means all nodes have the same protocols, there's only one kind of routing, one kind of data storage, so it's nothing complex. So you see the difference more when we look at hierarchical overlays. Hierarchical overlay is where you have overlays with dedicated functions, and some nodes in the overlay are themselves overlays. So here, for example, you have one blue overlay, and then you make your routing, and this is the node where you come, where you end. And this blue node here is itself a new overlay, which is then used to find some content, and this red node is itself a new overlay. So you might have virtual nodes in the overlay which themselves consist of networks. It sounds very complex. It is very complex. That's why they are quite rare, and typically you have only 2 layers only. But it's good to know how it works. And yeah, like it said, you have virtual nodes. They act as gateways to other networks. Overlay is clustered. You have these different layers, different ID spaces. Quite complex. Yeah. Something like this we also have in the peer-to-peer framework, I must say. But we will see when we come to talk about the monitoring. Oh, that's it. Okay, pure, hybrid, centralized, flat, and hierarchical. Good. That's so far to the overview on the overlays. What time is it? I have to just check. Okay, we still have some. Okay, good. Then for the rest of the slides, I would like to talk about these peer-to-peer systems, unstructured ones, to give you an idea how they work, because it gives they are quite good accessible, so they give you a good idea how peer-to-peer networks work at the end. In the next lecture, we'll have a look at the structured overlays, and especially on pastry, which we use in the peer-to-peer framework. Also, in the next lecture, we'll then probably start with how data storage is implemented in pastry and what we have to look at. Okay, but first, the unstructured overlay networks. So the simplest one is the structured one. Yeah. Here you see also some overview where we go basically through. We'll have a look at centralized homogeneous. I'm not sure whether we will touch heterogeneous. Probably it makes sense because it's a good way to handle weak and mobile nodes. And then we come next week to the DHT-based overlays where we have lookups, and here on the left side we only have search, basically. Yeah. Yeah, and also later on we will have a look at this heterogeneous peer-to-peer overlays. Yeah, that I was missing. So I was wondering, so one slide is missing. So hybrid, because there's the classification missing in homogeneous and heterogeneous overlays. Okay, so before uploading this slide I will put it in. But that you should also know, there's also one more classification in the overlays, and that's homogeneous and heterogeneous overlays. And the homogeneous overlays are like that one. And that's the simpler case where every node has the same role. So you have one bunch of protocols, and every role, every node fulfills it. So you don't have different kind of roles. And the heterogeneous overlays, they introduce different kind of roles for different kind of peer capacities. So if you have very powerful peers, then you get a different role that you take place, that you implement in the overlay. And if you have more storage space, then you have a different role. And if you have, if you are very long living, then you have a special role. So heterogeneous overlays introduce different roles that makes use of the capacities of the peers. Yeah. I will put that slide in. Okay, and yeah, that we will also see next week, probably in 2 weeks, because we can also extend this kind of simple storage or ID-based lookup overlay with the support of stronger nodes, because that's something that we have to address, and we will see what is implemented currently in the peer-to-peer framework, which idea. It's a first estimation, first idea, but it's not very good. Okay, let's start with the simplest unstructured overlay. So what was unstructured? Unstructured means we have object names, okay, but they are not really bound to a specific peer. And the simplest unstructured overlay is the centralized one with Napster node. And every node tells, I have this specific files. And if somebody else is looking for the object, then they ask the central server, do you know some nodes who has a song by Justin Bieber? And if yes, so he gets back a list of file names and a list of peer contacts, and then you can contact directly between the clients, and file transfer it takes directly place. Okay, one slide, simple overview. Problem, of course, the central server. That was also a problem with Napster. It was shut off. That's a bottleneck. That's single point of failure. But the communication is still peer-to-peer. All the resources, both bandwidth, storage, and the content is at the nodes. So the indexing is just done by the central server. And that was also the motivation. Okay, Napster was shut off. Okay, this is how the communication takes place. Yeah, I have the file, so I tell the server I have the file. Then somebody over there, node B, asks in the step, where is the document D? Do you know someone? And the server says yes, A stores it, and so they communicate directly. Okay, that's very simple. And yeah, that was also the point what happened to Napster. The server was shut off. They were claimed to support copyright infringement, and not just legal, and yeah, not just legal usage. Okay. Okay, that's very redundant. So history, yeah, it happened. They were shut off. Now it's, I think, just a music store with streaming. Okay, it's not that complex. Okay, so do you have any questions on how Napster worked? I think, why do I have 5 slides on it? Okay. Okay. And where do we also have this principle? So in ICQ, I think that it's also the case. I'm not sure. So 430 million registered accounts, probably quite old. There's probably a higher number nowadays. Was one of the first instant messaging tools, and it also supports this peer-to-peer communication by having a central server as in helping to create a connection between the users. So it's not just so the statement is this Napster approach just does not just take place in file sharing and just in Napster, but this simple approach also takes place in other kind of applications, like for example ICQ. Okay, so what happened next? So Napster was shut off. Now we come to Gnutella 0.4, and what happened is, yeah, Napster was shut off, and in the meanwhile, somebody, so Nullsoft, the company who also made Winamp, they published the software for Gnutella, the code, which was having the same functionality but without the server. So the point was, all nodes are equal, so we do not need any servers, and they connect somehow to each other. And if they join the network, they just depend to some other nodes they know, so they don't need any server. And any node can be shut off. We will always have a graph. The nodes will be always connected to each other. Every node has 20 or 30 contacts at least, and then when one node goes offline, it doesn't care, that doesn't matter. So it cannot be stopped. Which tasks do we have? So previously you had to contact the server. Now you don't have a server, so you have to know at least one peer in the network, and you have to advertise yourself once you are connected to at least one node. Then you can tell over this node, please send around my advertisements so that other people connect to me, and then you are connecting more and more other nodes in the network, and you become part of it. Okay, now you are part of the network, and now you can search for content in different ways. Broadcast, it can ring, random walk, rendezvous. At the first 3 we'll have a look what you can do. And let's assume you perform the search mechanism, then you get the results, a list of content that fits your request, and a list of nodes having the content. So you ask some of them, please send me your file, and they send it to you directly. So that's the main idea. No serving involved. And there are different approaches how the search can take place. Just one question. So, okay, after broadcasting, the question will come. So, when you don't, so let's assume you have this graph and every node has 30 contacts and you don't know where content is located, so you really want to have this Justin Bieber song and you don't know where it is. So, what can you do? You can send a message to all your neighbors, like it's presented here, to look for that object. So you are looking for MP3 file from Justin Bieber, and you tell maximum time to live to the message, so how many hops it can go. And then every neighbor forwards the message to every other of their neighbors except the one they received it from, and then it's flooded across the network. And what you also do is to have for every of these requests a request ID, message identifier, and you remember where the message came from, the request. So once you have an answer to this request, let's say that node has a fitting file, then it knows where this request came from there, and then it can send, okay, I have the file, this is my contact address to this node. And this node knows, okay, the request ID XY received an answer, and this is the address, so I will also forward on the request where it so I will forward the address of the query hit to the node where I myself will receive the request from. That's from here. So going the same flood back, basically, the path of the flood back, you will receive the answers of your query. And it has a lots of high effort for searching. So here's an example. I hope oh yeah. Okay, what do we see? So here's the green node. He's interested in having a file, and that's some node that has the file. And every node sends around, so just broadcasts the message and avoids double broadcasting. So if he received already the message, he doesn't broadcast it again. And you see with increasing hop counts, after 5 hops, so starting with 1, you come at the node and you have 43 messages sent and lots of traffic. And now the question, so you have lots of messages sent, so you really need lots of bandwidth. So to which company did Nalsov, the founder of Nutella, which used this principle, belong to? Do you know what kind of company that was? Generating a software which asks you to generate lots of traffic. It was AOL, selling internet access, and if you want more bandwidth, then you can pay more. Okay, how can this be made easier and simpler to not flood always the whole network or a large part of it if you're looking for Justin Bieber? We could start with a small time to live. So the hop range is, for example, first 3, and if we don't find in this small hop range the content, then we increase it to 5, and then if we still don't find it, then we increase it to 7. The drawback is that when you increase it, you still flood the same nodes that you flooded before. So you, in the worst case, if you increase from 5 to 7, you still flood it through all hops in a hop range of 5 that you already did before, and you know you won't find it, and only then you can go to hop count range 6 and 7. So it involves more costs, so why should it be better? And it is better because there was one guy called Zipf in the 60s, and he found out, okay, people and are interested in things, in content based on their popularity. And this popularity distribution is termed after Zipf. So that says basically the most, if you have one most popular file, it wasn't files that days, probably hats or shoes, I don't know. But if you have most popular something, then the second popular is, let's say, only half as popular. So the number of requests is only half as high. And the third is only half as high as the second. And the fourth is only half as popular as the fourth. So you have this specific fraction that you apply to the number of requests for popularity I and popularity I plus 1. And this fraction is always stays stable, basically. And that's something he found out. And what you can say, what is the conclusion, is we have very few very popular objects. So Justin Bieber is very popular. And that means that there's a high probability, if you are looking for something popular, and so the probability that you're looking for something popular is high, and that somebody else has this popular item is also high, and you have therefore a higher chance that you have it in a close neighborhood of you. So a hop count of 3 will be good for most of the queries. Only if you look for something unpopular, which happens rarely, you will generate more cost by going to hop count 7. So basically on popularity, both of the request and what is provided, this approach makes sense. Zip distribution, good. Okay, what it tells, it's good to know because it always occurs. What it tells, let's assume we have a fixed number of elements, 1000, and then we can calculate and k be the rank, so the number in the list at which the specific object that we look at exists. So element I is that the 623rd, 34th, should not be th, most frequent one to occur. Okay, and S is the exponent characterizing the distribution. That means, for example, if this would be, let's say, so this is 0.6, that means the most popular has a specific probability. The second one is 0.6 times so high, so it's decreased, and the next one is again multiplied by 0.6, and so on. And if you plot it to a log distribution, log scale, then you can somehow say the probability that this specific object is called or requested is depending where its rank is. So if it's the most popular, then the probability that it's called is 1 to the power of 0.6. And for every, so the further away, the less popular the document X is that you're looking for, the smaller the popularity is. And the TIFF distribution looks somehow like this, that really you still always apply the same fraction of multiplication to the objects. That will occur more often, so I'm not sure whether you got the idea, but that will occur sometimes. Okay, another way to approach to find content are random walks. So here the idea is, okay, I'm still somewhere in the middle of the network, and now I want to reduce the message overhead, and I do not send out my request to all objects, but only to selected ones. And let's say I have 30 contacts, then I say every node should send out this request k times. So multiple random, no, sorry. Yeah, doch, multiple, so k times. And then in every step, the message does not split up 30 times, but only 2 times. And then you reach less nodes with the same hop count, but you can control how many nodes you reach. Because in broadcasting, you didn't know how many contacts the node had, so it might also be that one node has 100, then it really explodes. But this time, hop count and TTL really, the TTL and the number of split ups, so K, really define how many nodes are found. Okay, again, so it took me ages to create a slide. So, and I cannot change the 3 to be hidden in the beginning, but just assume it's not there, and now let's enjoy the show. Okay, so here it's split up in 2 messages every time, and you see it really takes, it's slower, and you have less communication, and in total a higher hop count. So what happened here, so random walk K or N is 2, every incoming message is sent out twice, and overhead is smaller, we only have 30 messages in this scenario in comparison to 43 last time, and we have a higher hop count. It should be 7, not 6. So less costs, but also more time that's used. Yes?
Could it happen here that we have not reached all nodes?
Yeah. So it can happen that we do not reach all nodes, and yeah, that's the drawback. Also, yeah, it might be that you don't find your document. So that's always also the problem with these unstructured approaches at the end. That it might be that you don't find the object, although it's there. Also with the broadcasting, if you look for time to live 7, and in all these ranges that your document that you look for is not there, but in hop count 8 or 10 it would be there, then you still didn't find it. And so it's only probabilistic that you find what you look for. That's the main disadvantage, and that's also the reason why we don't use it for the social network. For file sharing it's good. So I do not care in file sharing when I only get 10 instead of 11 Justin Bieber songs. But I do care in a social network if I look for Alice and I don't find her, or if I look for my friends and I only find 80%. That's not acceptable. Okay, just one short words on rendezvous systems. They also exist. What you can do is you can, here you have the violet node, which has the object. And you have the green node, which wants the object. Other way around, sorry. So the green one has the object, the violet one wants to have it. Dark gray on left side. Okay, so what they do is you send out something, what is a bubble. The bubble is something like a small broadcast with a specific time to live. And here with the green lines, all the nodes that you contact are marked. So you leave the information when you want to store something. I have the document at these nodes. And the other node, the blue dark gray, which is violet, does the same. So if he wants to have the document, he also sends out the bubble and says, I want to have it. And these nodes are contacted, and you have some nodes with high probability where you have a match of the advertisement bubble and the search bubble. And these nodes can answer, okay, listen, there's this green guy who has the object, you can download it from here. So what is changed here is that the nodes do not just keep the content for themselves, but they make an advertisement bubble, you make a search bubble, and when you have a match, then you found the object basically. And this new advertisement bubble, this is new. Also, some words, we won't really go into detail how that works. So, why does it work? And how large do the bubbles have to be? So if you have a really big network, you have to create both a sufficient large number of advertisements, so the bubble should be large enough and the search should be big enough, and the probability is O of a square n. So if you have n many nodes, it's square n how the bubble has to be big in order to have a high probability for a match. And that's also the birthday paradox, which asks how many students or persons do we need in a room that the probability to have 2 persons at the same day birthday is above 50%. Do you know how many people you need in a room so that the probability of 2 persons having at the same birthday is higher, 50%? So there are 365 birthdays possible. So how many persons do we need? I think it's 17 or 18. So because that's the square root of it. Okay, so this is just for, I think for the unstructured overlays. This is just the overview for it. For the peer-to-peer framework, the unstructured overlays do not really take that relevance as we use structured overlays just because of the drawbacks that I said. Because there's always the problem, also if you do not choose your bubble high enough, or you have some bad luck and you don't have a match because you just come here with your advertisements and with your search only there. So in any case, it's probabilistic that you find the content. And if the content is there and you do not find it, either you invest lots of traffic to find it, in the worst case to really ask all nodes in the network to have a broadcast with maximum time to live, which is very expensive, or you have the chance that you don't find the object or loads there. And that's where the structured overlays are better. They invest some traffic in maintaining a structure so that you find the object based on its ID. And that's what we will have a look at next week, I think. So what's the time? Let's say. Okay, then we are good in time. So then I would say we meet next week. No, we do not meet next week. Next week I'm not here. But there will be a recording So I will put the recording online, and I ask you to have a look at it. So that's how we approach. Okay, if you have any questions or something else, then ask me a question or write me an email, and see you then in 2 weeks.